Hi there.
Hello, Terry. How are you?
Hi. Yeah, good here. How are you? Warm?
Good. Yeah, so warm right now, but you must be cooler and nicer on the island.
Yeah, it's quite pleasant here at the moment.
Yeah, I bet. I bet. Do you sail?
I used to. I don't get time nowadays. But
Yeah. How is everything? What do you? Because I haven't spoken to you that much recently. How do you feel about all the new changes with Jenkins X3? Like, how does that fit in with your work?
yeah, so I'm looking forward to getting stuck into that and making sure that all the MLOps stuff is moving ahead on that.
Yeah, good, good, good. And have you yesterday was up as a PR. I don't think it has been merged in yet. Have you seen the PR for the Jenkins X3 docs? Because that will enable you to play if you need more direction, because it's a bit of disjointed now. It's a bunch of pieces. So if you
Yeah,
wanted to have, a walkthrough of how to get started and things like that and give some feedback on the docs. Have you seen those?
I have. Yeah, and I've also been reading the code base as they've been
Yeah.
posting it. So I've got some idea of what the structure is like now.
Good.
But
Good.
yeah, I just need to make some time to actually fire an instance up and start playing with it.
Good. Okay. Nice. Yeah. It's quite exciting actually. They're good changes, I think.
Yeah, I think we're moving to a much more mature structure now, which should be a lot easier to manage.
Yeah. Yeah, definitely. Whew. So I wonder. Oh, here we go.
Hello.
Hello, Michael.
Hi
Hey,
there.
sorry. I was chatting to James's Rawlings and Strachan just before, so always goes over time. So, how are you folks doing?
Yeah, all good here, thanks.
Good. Yeah.
Yeah, that's doing all right here. It's the start of, I've got a t-shirt on because it's the start of, it feels like springtime here, so I'm pretty happy about that. Today was, it's pretty short winter here, so I can't really complain. But the day's getting longer and it's getting warmer. I think you're just getting over your heat wave, so I think ours is about to start.
Yeah. Looking forward to that.
Yeah, that's unpleasant there in the heat. So, yeah, I guess this week, did you have anything you want to bring up, Cara or Terry?
So, from my perspective, we're just finished off the last few items in the
Yes.
technology requirements section.
Yeah.
I've done another 3 this week. We just need to fire through the last handful.
Maybe we could. I forgot to take a bunch of notes last week on some of those points we were talking over, so maybe we could tear into those last 3 today. Maybe if I shared a screen and typed, we could do that. So before that, I had an interesting discussion with Metaflow and Netflix. So Metaflow was something I think I mentioned last time. And so I spoke to, I guess, the lead developer of that from Netflix. And they are interested, like they were very interested in the MLOps roadmap. In fact, he said he was working on an internal memo at Netflix to sort of pass around on their sort of principles of MLOps, which overlap very much with this. So he's going to take another look at it, and if he can share it with me, that would be good too, because it's kind of a large scale validation of some of those ideas. There was a really good blog they put out recently. They did integration with Amazon step functions. So they use step functions as a back end for orchestrating the workflows. So Metaflow is more like a high level sort of flow config that just glues different tools together. And behind the scenes in Netflix, they have sort of a closed source orchestrator, but they wanted to make it work with something that was off the shelf. So that was Amazon Step Functions. So that could be something else. So he was interested in Tecton from that point of view. And he mentioned it's a sister project of Spinnaker. So he was very aware of the CDF. So it could well be, if it becomes successful the way Spinnaker was, it could become, they could become interested in the CDF, which I thought was interesting. But we'll see. At this stage, they're kind of sort of thrashing pretty hard on it, and they're getting outside contributions and stuff. So, you know, they want that to sort of settle down and to see it has some life to live outside of Netflix, and then they'd be interested in perhaps looking at a place to host it. So I thought that was interesting, because to me, I view it as sort of almost like an instantiation of a lot of the principles in the MLOps roadmap. Maybe not all of them, but I guess that's part of the idea of that, is like here are a bunch of challenges and requirements and possible solutions, and this is one of them that, you know, that solves, you know, a bunch of these things.
Yeah,
it definitely comes from the angle of building stuff for people who are interested in data science and machine learning, not necessarily only data scientists, but heavily on the data science side. So building tools that guide them to do it the right way, but are not too prescriptive. So it was pretty interesting, and they run things at quite a scale there. Like he was saying, they, you know, for multiple countries, they would do maybe train a model for every language in that country. So you can imagine the fan out of that, and they're retraining that based on some of its cron schedules, some of its when the data becomes available from some upstream data source. You know, there's probably other systems in Netflix that batch things up and so on, or maybe just a certain amount of viewing data, and then they do it for all sorts of experimentation as well. You know, maybe even planning what to film and stuff. It was fascinating. So I know this is recorded, so I can't share everything that he sort of talked about, because, you know, Netflix. But it's fascinating. So they're kind of applying a lot of these principles at scale, and doing it in a way that everyone in Netflix that does machine learning and data science sort of goes through this platform. So I thought that was a good validation of some of these ideas, and there was one blog post, I just put it in the show notes, the minutes, Metaflow, Amazon, which I thought was a really good blog post on the philosophy of it from a data science point of view. So there's a link. Why can't I edit that doc? And I'll paste it in the Zoom chat as well. So I thought that was a really good read on their philosophy of things, and why they use a DAG, a cyclic graph, to do things. And yeah, so that's worth a look. Hi, is that Almog? I'm not sure if I'm saying your name right. So I'm not sure if you've been here before when haven't been here. I don't know if we've met. So why don't you introduce yourself?
Hi, I've met on the other meeting with Terry. I'm a technical entrepreneur, founded a few companies, and now I'm investigating and researching about the innovation in the MLOps world. So I'm here to listen and help, and whatever you want to do, I can help. Awesome. But feel free, please, to ask me to do stuff. This way, I'll do it. You know, because if you ask, I can't say no.
Yeah,
I already volunteered.
Yeah, well, it's great to it's great to have you along. Yeah, it's an interesting area, the whole MLOps thing. The more time I spend on things, the more I realize a lot of it's about just handling the data. Like I must have spent most of the past week just trying to, I'm working on a conversational sort of user interface right now. There's a bunch of different models that are doing things behind the scene that are, they can take their time, they prepare the data, but then the sort of more real-time stuff is I'm finding a bit frustrating because everything's time sensitive and it's all about getting the data in a timely fashion. And yeah, it's most of MLOps seems to be about handling data. It's almost like by the time you get to training the model and deploying it, that's the fun part. Like that's the it's a dangerous part, but it's also the fun part. So yeah. I guess the next thing was last time we mentioned about any RFPs and conferences and things like that. Is there anyone had done any submissions or heard of anything interesting to start sort of evangelizing or socializing the roadmap?
I think we've probably missed most of the events this year. Things tend to peak
They're already
August, September
right.
time.
Yeah. Yeah, so I guess it's I'll have to keep an eye out. Has KubeCon closed? I don't know whether this is in the remit of that, but they certainly would get a big audience. I'm pretty sure their main event is late in the year. I don't know if there are. KubeCon, Cloud Native Con. No, it's in August. Oh, that's the Europe one. I said they still got a Europe one, and they'll have a US one later in the year. Isn't that funny? Even though it's all online. Sorry, Cara?
The North American CFP for KubeCon is closed now.
It's closed. Okay. All right. Yeah, that's probably the big one. Anyway, thought I'd follow up on that. So I guess the next thing is to dive into those final few items. Did you want to share your screen, Terry, or did you want me to?
Yeah, no problem.
So I made a change to the online learning section. Changed the wording to say it's not out of scope, but it's not something we're looking at this time. I think I use words to that effect.
Yeah, I think it'd be better to actually remove that bit as well. Let's just capture the challenge in there, and then we'll put a technology requirement in there, but we'll make it clear that more investigation needs to happen in the technology requirement. So
right. So just make it
the way
say
we should
something.
be structuring these things is that whenever we capture something that's a challenge, it should go into the challenges table.
Right. And we don't have to. We could admit that we just need more information. That's fine.
Well, what we do is we flag certain things as difficult challenges, which are typically in a long time horizon, and then that's the point of this, which we're going to come on to next. Is that this is basically giving an indicator of when you can expect certain capabilities to be available, and for something like that, which is very challenging, it may not be visible as a capability in this roadmap.
Sure.
But you would almost certainly be showing some work being done on it later on in the roadmap. So you would flag it as black research required, and then you would potentially not see any development activity on this time horizon, but you would leave it as an outstanding that somebody needs to pick up. And those are typically the things that some people will be very interested in, because they'll be looking at the longer term wins and where it's worth investing in a big bet for something downstream. I've added some extra pieces in here with respect to managing assets and security. So this is the latest PR, and then I think what we've got
just
left.
Making, I just updated my wording, by the way, to the challenges one. So so we got these three.
Yeah. So we've just got these ones. So let's go back and look at the challenges and see what we've actually identified, and then that'll tell us what we need to discuss to go in here. So margin tracking trade-offs. Yeah, so this is an interesting one because you know, the practicalities of models are that there are nearly always some sort of trade-off between different factors, and there are often going to be conflicting drivers on customers as they're trying to build solutions.
So are these trade-offs in terms of almost design decisions? Like currently, I imagine if it's sort of a human factor, then it would be a note or it'd be some comments in a notebook or a document somewhere saying maybe you couldn't do things at the zip or postcode level, but we had to reduce the resolution to be, the trade-off is we couldn't be as fine-grained because of some legal constraint. Or one thing I was looking at was tracking sentiment and things of individual comments that could be traced back to individuals, which is not always what you want, because that sort of information could be used the wrong way. So would a trade-off be that you deliberately almost blunt the system, or you blunt the data in some way, as a positive trade-off for privacy? Or in some cases you go, we require this personally, these pieces of personally identifying information to train the model, but it's not going to affect, you won't be able to go backwards, and you have to explain. Am I on the right sort of track in terms of what you mean by a trade-off?
Yeah, I mean, and often different types of compliance actually introduce competing trade-offs. So, for example, if you're faced with GDPR, but also some new AI legislation about explainability, those things will be in direct conflict, because the more explainable you make the solution, the less privacy there is, because you have to link back to individual events in the data to be fully explainable. So so there are going to be certainly big trade-offs in a triangle between accuracy, privacy, and explainability. But typically there are multiple other areas where you will also have these sorts of trade-offs, where there are basically different features in a data set, and you can't optimize for all features, so you're ending up with a balance between weights on certain features that will give you a certain behavior out of the system. So the overarching piece here is that we need to recognize that that's the base reality that we're operating against, and that actually we should be providing capabilities that embrace that and help customers to manage their assets within that environment. So, for example, what you might want to be able to do is tune parameters in such a way that you end up with several models as points on a continuum between different endpoints in the trade-off space. So say you've got a triangle represented by the extremes of accuracy, privacy, and explainability. What you might actually want to do is try and train a bunch of versions of the same model that sit at different XY.
Right, and you might find you might find one that doesn't give us away as much privacy as you thought is still adequately explainable and accurate.
Yeah.
And yeah, there's ensemble sort of things, and AutoML tools can do things like that because they just try a bunch of things and you just pick the. In fact, Netflix do that. That was one of the examples they use in the Metaflow, is that they would do 100 different variants of it in parallel, and just sort of almost brute force it out, and then pick the one that's that's part of the flow pipeline, would be to pick the one that's good enough based on some constraints. And some of those options would be, in this case, might have more privacy challenges than others, and then you could weight it accordingly and pick the one that, if you value privacy over all else, you want to be as explainable as possible. But yeah, I like that triangle idea. So could we just take some notes on this, or should we open a pull request and just put some dot points of what you just said, because it's easy to lose track?
Well, I'm happy to write that one up because I've got a fairly clear idea of what.
Okay. All right.
That one should look like.
So the next one, the triangle things are great. I don't know if we can't really include a visual in there, it would look a bit weird, but if we could have that somewhere, that's kind of an interesting idea. It's like what's the distributed computing version of that? The durability and availability and the CAP theorem, consistency. It's almost like the CAP theorem. There's always three, isn't there? Like, and you got to pick, pick two or pick one. Oh, that's fascinating. Let's take a note in the minutes on that. I thought that's good.
So with the model training as it's done now, usually these formulations that are checking many different variants of a model, they like in different parameters, they are looking at precision versus recall. Often those are like two standards. So this would be beyond that, your whatever system you have in place to compare your different potential.
Well, I think
would have all.
I think what they. Sorry.
Would have multiple comparison points then. So it would just be like this enormous branching tree almost of potential models and results at different comparison points.
I don't know for a fact what Netflix do, but they try all those permutations of hyperparameters, but I am guessing they're just looking for accuracy. So that's simpler, but yeah, you could have some other, I don't know how, and maybe this is part of what Terry's thinking for the requirement, is like, how do you sort of quantify the privacy trade-off? It's how many, maybe if there's 10 features of personally identifying information, something that uses 3 scores better in privacy than something that uses 7, maybe. Like if all 7 features are used to train the best model that has better accuracy, then, although accuracy and precision have a specific meaning in models, so the goodness, like the more gooder, I don't know, the best model by some whatever your metric is
So
that
you
you're
think
choosing. You kind of have to, that's the trade-off then, is if you could say, I'm using 3 of these, but I get this score, or I use 7 of these and I get that score, the trade-off is that, well, that score is actually good enough. So I'm gonna, or that score's not good enough, so I'm gonna take more of that PII features in there. Is that right?
Yeah, so I think the existing situation is, to a large extent, people set thresholds and then they're aiming to get one parameter above a threshold, whereas the practical application in the future is going to be much more about having to tune for the best compromise against multiple parameters. And so you may end up deploying a less performant model because it's actually safer or more legally compliant. And I think we're probably looking at a future path in which the solution is more like evolutionary software than conventional single path CI/CD, in that what you'll do is you'll spin off multiple parallel trainings and try and get them to resolve against different points in our triangle, and then you'll compare the behaviors of those against a set of overarching tests, and then select from that group one which is the best compromise for the application.
Yeah, you have to have something that makes a decision, and so that
if I can ask for, so for now, currently, for what it looks like, the measurement, the KPI for a good model is how accurate it is. And what we're saying is we need to add more measurements to see. It's like a triangle. It's a fairness, accuracy, and privacy. And you need to take in account all of these, measurements in order to decide which model you choose.
That's correct, yeah.
So interesting. That can be a whole, we can write a whole article about.
Yes,
Yeah.
it is. And I don't think anyone's really, it's probably, maybe people are already doing this, but it'd be surprising. But I imagine you could come up with the way I think of it is that you'd have a set of so many features that you may or may not use in one of those permutations. And then when you look at the output of that, you've got all the precision and accuracy of the model itself. And then you've got how many features of those set were used. And then you could have some formula that comes up with some aggregate score. And then that thing decides which one that you pick is. I could imagine people, I'd be surprised if people are doing stuff that advanced.
The formula is also quite different sorry to be rude, but let's take Russia as an example. In Russia, they don't really have a problem, recognizing Black people, because there are no Black people in Russia. Like 99% of the people in Russia. So probably if I were a Russian company, that wouldn't be an issue for me. So I'll prefer a more accurate than fairness of skin color,
Yeah, the biases come into it at that point, based on the data. And I guess the role of MLOps there is to have that sort of trail or record of how you got to there. Like people will ask, how come it doesn't work for this group of people? And then you can go back and go, well, here's the training set of data. It's from this nation or this city. They're not represented. And then you can go, well, that's a problem. How do we do that? And then you could inject extra data, or you could add I guess, unit tests or acceptance tests, if you like, to go, well, we won't accept a model that doesn't, at least work for these cases, and fix it up that way. But yeah, there's definitely a role for MLOps to look at that. But yeah, this is something that people are discovering every day. Like there was that, I think it was a Kickstarter startup the other week that was guessing people's gender based on their email address. Is that right? It was all over Twitter, and it was pretty obvious it was a bad idea.
Yeah.
Because you put in, such and such a name, which could be anything, and it would say a 60% chance male or whatever.
I
and then
know
you put in
well,
doctor, and it says 100% chance. Yeah, it's just, so it's like it's codifying the biases of, and then they were saying, the people, the project got cancelled, but people were saying, oh, but this is just reflecting what the data is. But I think, we're at a point where people aren't accepting that. It's like, yes, the data says that, but we should be doing better than just echoing kind of what the real world has. So yeah, it's definitely one of the challenges. And I guess the idea of surfacing it in these pipelines that are more traceable and explicit, then people can maybe catch this stuff more early on rather than late.
So that actually brings us on to the next item, which is pretty much the law of unintended consequences.
Excellent.
Because if we actually have to validate all of these models for fairness and bias, then that means that we actually have to hold special category data that actually indicates things like race and religion, gender, sexual orientation, stuff like that, because we need that data to actually detect the bias. So that means that you end up having to then hold a whole bunch of sensitive data that massively increases the privacy risk in order to attempt to decrease the fairness and bias risk.
Wow.
So what we're going to see is a whole period in which there are knee-jerk legislation attempts to fix the problem, and those knee-jerk responses will actually make things worse in other areas, because we'll get more data breaches as a result of having to store more data to address the previous concerns. So to an extent, this is like trying to push down bumps in a carpet, that the best you can hope for is to get them all under the sofa where nobody can see them. But what we will need to do is think about the technical implications of this, because we will need to have a high degree of security and privacy management in all of these MLOps solutions, because they themselves will otherwise be a large vulnerability in all of these application development stacks. So this piece really needs to address data classification and data protection, and also, probably some degree of auditing in terms of managing the day-to-day level of sensitivity of the information that's flowing through your MLOps system.
So some of these, so when you say special category data, some of that's in different countries, it's protected data. There must be already in place some exceptions around that. Like, for example, insurance policies for vehicles or other things, even life insurance. Here, certainly, they find out quite a lot about you. In fact, you're obliged to tell them. But normally, in a normal workplace, professional setting, they can't ask that. Like in my country, you can't even ask someone how old they are professionally. You can't ask about their marital status or any or religion or ethnicity. Any of that stuff is you can't actually ask it as an employer.
You said age. They can ask about what? How old are you?
No, they can't. Yes, you're not actually allowed. But everyone volunteers it. I mean, there's certain forms you write down your date of birth, but like there's rules around age. But obviously, you need to know that for getting. That's a very trivial example, but for getting a car insurance, for example. So I assume there's already some. This isn't really technical though. There's already some prior trodden path here around handling data because of insurance companies and banks and things like that. So,
so how does they handle it? If an insurance company can't know how old are you, how can?
Oh, they do. That's what I'm saying is they do know. So they must have some special exception, or it's yeah. So there's. I guess that's the more on the legal aspect, but I guess my point is more that this isn't the first time sort of this handling of this sensitive data, protected data or special category data, it has come across banks and insurance companies all over the world do this every day. Maybe lawyers, but then they probably, it's filed away in a cabinet or it's probably on a USB drive that they just leave at a bar or something anyway. That's how you hear about this stuff. But yeah, I guess I'm saying is that in terms of the data security, it might not be that there's new solutions or anything required. It's more that considerations for the data might matter more here than say a typical software system. The data, you could argue the data is more sensitive, so someone building one of these systems should be more aware of encryption at rest, or Google even brought out that system that has things encrypted, almost all the way to yeah. So the data stays encrypted as long as possible. How it's these are things you might not care about if you're building an e-commerce system, for example. But if you're building an e-commerce system that was tracking every click and every transaction ever, and a whole lot of other things, the customer and maybe their mobile app that they're using that tracks their location, then suddenly you've got I guess an escalation of data potentially that you would have to handle more carefully than you would in the past.
Can I just ask, it's more of a, I guess, slightly technical question, just checking something. So we need to have this in the way that we've structured it in the roadmap. The more sensitive data needs to be collected and kept in order to check that your models don't have bias. That's how we have it structured here, like unintended consequences kind of thing. That is because you should split your test data from your overall data set and keep it separate from your training data. This would be a difference from that standard practice, which is probably best practice for checking your model. But if you had data that had been cleansed of all more anonymized, so weren't collecting this data, and if it existed, it was being taken out of the data set, and you trained your model with that, could you have synthetic data to check for biases? So it wouldn't have to come from the same.
Make up a fictional persona or something that fits the criteria. Like you might be looking, so it's not a real person. I guess that would be, if you can do it in volume, then that would be ideal. Yeah, I think so.
The challenge is that the bias is in the data rather than in the model. So
yeah.
So you're actually needing to add information into the model, into the source data, to flag the fact that some of the items have bias, so that you can then train against those to even out the model that you get. So you actually have to add data to the training set to indicate the the degree of skew in the data set.
But that's assuming you know that degree of skew. And a lot of the times, I mean, partially it's just people not thinking about it. But when you think of things like the mortgage scandal, where certain postcodes, because they were predominantly Black postcodes, were really penalized under this AI model. Okay, so in that case, yes, we have bias in reality, and that will be shown in the data, even if you're not collecting for it. But what you could have is you could have a data training set that was checking for this. Like the model you've used, does it actually in, real world, but synthetic real world, would it result in, all these side effects that we don't want, say racism or sexism or whatever. So that would be enabling you to keep your data, keep some sensitive data out. And of course, like different models, like if you're in medical care, like you probably need a lot more of that data. But, for a lot of models, you could keep it out of your training data and the data you collect, and then you could have it be checked for in your test data.
Yeah, I think that the challenge here is that in order to detect and in order to rebalance, you actually have to be holding information about the sensitive things that are being detected by proxy in your original data. So that means the requirement to add fairness also means having to hold more sensitive data.
Like perhaps the specific examples, it might be easier to synthesize data. Like it's not uncommon to synthesize data to balance some training set, but you have to know a lot about what you're synthesizing, because it's always risky to train on data that isn't real, but people still do it. Like people will balance data sets and drop a certain percentage of things to, like in this case, Terry, how are you, if there was some bias detected, it's like, it's one thing to sort of fail and reject it. But how is that corrected? Like this data that you've got, this sensitive category of data that you've got your hands on, does that have to be fed back into the model itself? Like it does, doesn't it? If you want to correct it with real data, you don't really, or can you adjust weights on things? Like maybe it's like with enough data, surely it's not completely black and white where the source data is completely missing a certain category of people, for example. It's just that it's very underrepresented. So can you just adjust the weights on the model, or would you have to synthesize or add more data to balance it out?
If you wanted an accurate model, then you would need to collect more data to balance out that category.
Yeah, I mean, in some cases you might not, because you might want your model to reflect reality, but you just hand code heuristics from the output of that. So you might, in the mortgage case, you might go, well, if the person's from this protected category, or we know these postcodes based on the data are problematic, so we will, we'll kind of use a more heuristic approach for this subset of the data decision making. I could imagine people doing that and kind of, almost hacking around it. You're using the model for where you want to use the model, and then you're using, ensemble approaches work that way effectively. They just have different models for different sections of the data rather than one big model.
Yeah.
So I'm sure there's lots of technical solutions there, but yeah, it's not if reality is biased away in a way that's not suitable for your business and its decision making, then you basically have to either bend reality or bend the decisions to ensure fairness and equity.
Yeah, but again, it's actually, from this perspective, it's irrelevant what the solution would be to rectifying the underlying problem, because you still have to hold the data to detect that there is a problem in the first place.
Yeah. Yeah,
and
that's I think that's the fun. Well, I'm just taking some notes. Yeah, so even if you could synthesize things to validate it for some parts of your pipeline or retrain it to correct the balance, at least initially, or probably regularly, you would need to be getting data into the system that is sensitive, because you wouldn't know. Like you could go a fair way with synthetic data, creating fake personas that match different things, but at some point that will drift from reality, and then you'll end up back where you started, where it's miscategorizing underrepresented people because your synthetic personas are not filling the gaps, right? So yeah, I guess that's the bottom line, is that the technology requirement is to handle sensitive data. Ideally, it's as little as possible, but there will be some. There's no getting around it.
Yeah, I think that what we're really getting to at this point is that pretty much by definition, every MLOps implementation will be forced to handle the most sensitive category of data, even if the customer that didn't anticipate that when they started. So it's like the customer may not have considered that as a requirement when they selected the product, but the problem domain itself inherently points towards a situation in which that classification of data is almost certain to exist in every sizable problem that's being run through it. So and again, I think this is one where this may not be obvious to developers of MLOps tooling, but we clearly need to set the bar a lot higher for this tooling than we would do for any other type of software engineering tooling, because
I mean, in traditional software, you would get, if you're building on a system that has a database of some sort, of pretty much everything does, then it's not uncommon for people to want to have some subset of the production data to work on. But in general, people won't have the whole copy of it, or they'll have a scrubbed version of it, or it'll be a very small portion, and it won't at all reflect the real production typically. In machine learning development and data science realm, that doesn't really cut it. So you're going to be handling what would be production data just to get anything done. Like it might be a subset of it to scale it down to get some algorithms right, but essentially it will be the real sensitive stuff, and it'll be a lot of it too. Like even a small subset is still a lot more. Whereas in normal software development, it would be fine to have a barely populated system, just enough to exercise the functionality. You would rarely work across a climate of the.
I think that's the point that we want to get across in the technology requirement. Is that all MLOps systems will be expected to work with highly sensitive data, and need to take that into account at a design level, because otherwise we're going to go into a period where there'll be multiple data breaches, and every time it's going to be somebody attacking the MLOps system to get access to the data.
That's a great point. I understand. I mean, DevOpsy type infrastructure is sometimes a fairly advanced target of attack, because it has its fingers in everywhere. And yeah, this just magnifies that, because if you've got every ML engineer with a copy of this sensitive data, that's a huge attack surface. It's all their laptops and things like that. And typically laptops, they're not as uniform and securable as a server is. It's just the way it is. They're very customized. So So I guess
And
there's
then-
one. Sorry.
I was just going to say that that also brings us neatly on to the next one,
Right.
which is specifically looking at different types of attacks that can be made against models, and how we need to consider that as part of the MLOps workflow.
So there's IP protection in there. So black box, is that to protect the IP, or is that to protect the data, or both? I guess it's the
So if
IP really.
if you've got access to a model, you can use that to train a copy of it.
Mm-hmm.
So if you treat it as a black box and just keep poking data into it, and then train a new model based on the input data and the output data, you'll eventually synthesize what the original model was. So that means you actually need to provide protections that can detect large amounts of data being fired at particular model services, because that might indicate that someone is trying to reverse engineer your model.
I mean that would be a similar pattern of attack to the other ones, like extracting data about individuals, membership inference attacks by just throwing data out and seeing if it does something different.
Yeah. So those again.
Yeah, they're all kind of related, aren't they? They're all abuse of the model or detecting a pattern of. Yeah.
Yeah. So there will be some standard ways of detecting and mitigating that. And those.
I guess the analogy here in for example, web apps would be protections against request forgery and injection attacks and things like that. There's a bunch of there's the OWASP 12 or whatever it is sort of things. There's obviously a lot more ways to attack things, but that's a good generic sort of baseline of things. So it's analogous to that. There's probably specific things you could do to protect and that, but yeah, these would be sort of the intrinsic protection. Okay, yeah, that makes sense. So
yeah, so that you would expect there would be a need for validation level tooling to allow you to exercise your models against things like adversarial attacks during the integration phase of your development. But then you'd also expect there would be runtime deployment considerations for all of these examples, where you would actually want to be able to deploy some capability with your model.
Like a web app firewall. There's all sorts of layers you can put in with web apps today. This would be similar for a model. And likewise, you can run test suites and fuzz tests against packages of software before they go to production. You can also
it's
have
like
a firewall to defend.
You see it's more like a firewall protection, or more like a sandbox where you put your model in and you run a lot of tests before production?
Both. I think both.
It's both, yeah.
Yeah. Like you would validate it so that you haven't done anything to make it worse. And then, yeah, at production, you have something wrapped around it that's sort of a last line of defense.
So again, using the OWASP model, you're going to have OWASP top 10 penetration testing done during your build, but then you would also want some sort of OWASP Rust style deployment in your application that is actively monitoring incoming traffic and either warning or reacting to adversarial attacks on the service.
Because a lot of if it follows the analogy of other software, most attacks are fairly generic. Like usually software is compromised by casting a very wide net, and then 1 out of 10,000 servers will respond with something. And there's also spear phishing and more targeted things, and social engineering. Social engineering is outside of the scope of this, and there might be a very specific model that someone wants to attack, in which case the generic things won't help a lot. But that's the same with websites today. It's you just know that all Google assets are always under attack all the time. I had a bunch of friends that worked on the Blogger platform. I guess it's still around, but Google, and they would come under DDoS all the time because there were political blogs on there, and there were state actors wanting to attack it, and their strategy was just to make things scale so much that the DDoSes weren't DDoSes anymore, and then they couldn't really prevent it, but they could make it strong enough and hardened enough so it didn't actually matter. So I'm sure there's analogies here as well. Although in this case, it's not so much a protection of I mean, there might be protections around availability, although generally models are fairly efficient at runtime execution. Maybe it's more the training of things, but it's more the IP protection and defending against inference attacks. So
yeah.
So I guess sorry, you go, Terry.
Just getting these done. I'm happy to definitely pick up the first one. Cara, would you like to write something about the data categories one?
I have so many hesitations about arguing that we need to enable more, to normalize more data, personal information gathering. I would be like, we need more protections. So I don't think I'm the person to write this, because I think what I individually as a human would want to argue is probably different than what you're heading for here.
But no, I think that's actually the point. The point is that what we're going to find is that from a legal perspective, governments are going to force us down a route that leads to having to capture more information, and that if we're not going to then create a big privacy problem, we're actually going to have to ensure that the implementations of these solutions are built to an appropriate standard to mitigate the risks of that happening. This is the unintended consequence thing, is that you're going to get politicians acting to do things that they think that will protect citizens, and actually those actions will create bigger problems elsewhere because they don't understand the consequences of the first action. So we have to think ahead of all of this and plan for the situation where we end up left trying to reconcile a set of poor decisions that are imposed on us in law, and make sure that we're not creating a technical vulnerability under those circumstances.
So you're assuming that governments will move further away from things like GDPR?
No, what I'm saying is that governments will introduce independent legislation that conflicts. So,
well, for example, a GDPR, whilst well intended, has an unintended side effect of strengthening the position of Facebook and Google in the face of other more diverse competitors. And that certainly was not intended, but that's one of the effects it has had, because no one else can really afford to operate in certain markets because of it. And that actually makes things worse for privacy, because it drives more data into Facebook and Google's hands than it would have before. So that's one example of an unintended consequence of well-meaning legislation. So I guess, Terry, you're saying that there could be a similar thing here if governments sort of act on
so
it.
what we're seeing is a large number of efforts to introduce legal protections over AI and decision-making systems that require full explainability. Now, full explainability means zero privacy, because you actually have to be able to trace in the model all the way back to the source data item that gave you that weighting. So that means that you actually have to reveal the identity of individual people.
That's a really good point, because so many people talk about explainability and I don't know what they mean. Like, it's other than that, like, are they thinking there would be some, like a human would explain something, which is how a human explains something is never really the truth. Like, you have to go back to how they learnt it, who taught them, and no one ever tells the truth of how they really know something. So there's this false assumption that you can explain without giving away the whole chain of things. So yeah, I think that's a great example of.
Yeah. So you and likewise, if you have another movement that is saying, you know, we're going to pass a bunch of laws that say models must be free from bias and they must be completely fair. Well, the only way to demonstrate that from a legal perspective is to actually record the gender and the sexual orientation and the religion and the race of everyone in the data set, and then show that your model is not discriminating against any of those factors when you run data through it. So you actually have to, by law, record information that you otherwise don't need in order to prove that you're complying with the legislation that has been put in place. You actually make everything worse by trying to make it better.
Well, I think I was going to look at the last one, the intrinsic protection, because that sounds interesting. The middle one, the escalation of data categories, I could have a run at that and then pass it around, and we can, or maybe we need to tag each other in the document and then flush things out there, because it sounds like there's more discussion on that. But certainly the last one we could definitely knock out pretty quickly, and then we just got this one. But I think I could have a go at it to try and summarize what I've written here. But other than that, I think I'm pooped. So we'll call it a day. And this is really good stuff. So if we need to next time, we can dig more into the escalation of data categories, because I think this is an interesting topic. I did see in the news this week in the UK, I think they have banned police departments from using facial recognition in crowds, which is fascinating. Like basically a blanket ban, or is that incorrectly reported?
No, they were very careful to word it such that it had no implications on the future usage of facial recognition.
Right.
They merely said that in the instances in which it had been deployed, it was not legal.
Right.
But they explicitly excluded that from becoming the general case.
It's too tempting. It's like, it's too, people want that sci-fi future of that you see in Hollywood movies where it picks someone from the crowd, and yeah, it's but I did see that in the news, but yeah, I thought that was interesting. So, all right. Well,
thanks everyone.
Yeah, thanks everyone, and good conversation as always, and some good notes and some good stuff to look at next, and then we can sort of go on to the final bit of the road mapping of filling in the squares of when things can happen and what might be out there, and yeah. All right, keep the ideas flowing and chat next time.
Thanks.
Right on.
Bye.